So here we are, 4.3a in elementary algebra, and we have done a system of equations in two different ways so far. If you remember, you're given a system of equations and we graphed it. And we found out that where the graph crossed, that point was the answer. Go over x and up or down y, and you were able to find the answer. We also learned that it was very difficult to be very accurate when you did graphing because you couldn't always just tell where that graph was. So then we went to the next section, and that was elimination. And if you remember, with elimination, we had problems like this, and you had to eliminate one of the variables. So get rid of that so that you only have one variable and you solve it, and then whatever y was, you plug it into one of the original equations and you could find the x. Okay, this particular section is called the substitution method. It is the third and final way to do a system of equations. And if you remember, when you were doing elimination, you would have something like this. And then you would have maybe another equation like that, and you would solve it from there. All right, we're going to look at some other equations here that don't look quite like that. In fact, let me put one up here next to it so you kind of get an idea of how different they are. Okay. Now you can actually make this look similar to that, as far as x's and y's on the same side of the equal sign, and be able to solve it using elimination. And you can actually solve these systems of equation by elimination or substitution, your choice. But some of the equations are easier to solve through substitution than they are elimination. So that's why we're going to go into this. So, what do we have here? We've got an equation. Let's just look at this. X plus y equals 2. But down here we have y equals 2x minus 1. Now what if we took the y equals 2x minus 1 and looked up here, and whenever we saw y, we replaced it with 2x minus 1. So that's what I'm going to do. X plus, and I'm going to put them in parentheses, whatever I'm substituting for y, equals 2. Now I can take the parentheses off. 3x minus 1 equals 2. I'm going to add 1 to both sides, and I get 3x equals 3. Divide by 3. Divide by 3, those cancel. X equals 3 over 3, or x equals 1. Okay? So, I didn't have to do anything to eliminate one of the variables like I did in the elimination method. What I did is I looked at one equation, and if y equals 2x plus 1, then I put that 2x plus 1 there, and was able to solve for x, because what happened? When I substituted x in for y, I changed it to one equation with one variable. The y disappeared. We substituted 2x minus 1 for it. Now I have x equals 1, and I can take this initial equation here and put a 1 in there for x, and y equals 2 minus 1 is 1. So my answer is x is 1 and y is 1, and that's what I would have for an answer for that system of equations. Alright, this is example 2, and again what we've got is we've got one equation here, and this equation here tells me what x is equal to. So whenever x appears in the top equation, I'm going to put 2y plus 7 in its place. Okay, now I'm going to distribute 4y plus 14. Combine like terms. So 4y minus 3y is 1y. Okay, now I'm going to subtract 14. And those go away. And I get y equals 12 minus 14 is negative 2. So there's my y value. Now I go back to one of the original equations. Doesn't matter which one. So either one of these. I'm going to take the top one. And I'm going to put a negative 2 in for my y. Notice I put it in parentheses. I always do that. I don't know if it's necessarily right or wrong or anything, but that's just what I do. 3 times negative 2 is negative 6, and that gives me a plus. So then I subtract 6, and I get 2x equals 6. X equals 3. So my answer is x equals 3 and y equals minus 2. Now, notice here, you can either write this as 2x minus 3 times negative 2, or 2x negative 3 times negative 2 is a positive, and get the positive here. Either way works. I usually do the latter and take the negative times the negative and get the positive. Okay, so let's look at example number 3. X minus 3y equals negative 1. 2x minus 3y equals 4. Okay, now this is very much like the ones we did with elimination. And the thing is, you'll be tempted to use elimination because sometimes it's easier, but the book is trying to teach you substitution right now in this lesson, 4.3. So that's what we're going to require you to do. When the book tells you to do elimination for some problems and substitution for some problems, you need to do that. When you're on your own, when you're doing math problems later on down the road, and it doesn't give you a suggestion to say use elimination, use substitution, use whatever you want. But right now, we're in substitution, so that's what we're going to do. And so in order to do substitution, when you don't have a variable equal to something, like here, we don't have an x equals something or a y equals something. So what I'm going to do is I'm going to make that happen. So if I add 3y here, and I add 3y here, I get x, those go away, equals 3y minus 1. So now I know what x equals, 3y minus 1, so now I can put that right there. So let's go ahead and do that. So now wherever we see an x, we're going to put 3y minus 1, and then minus 3y equals 4. So this minus 3y is that one. So distributive, combine like terms, add 2 to both sides, and we get 3y equals 6. Divide by 3, y equals 2. Okay? So now we take either one of those equations and we put y equals 2 in there. So let's take the top one. Add 6. X equals 5. So your answer is x is, whoops, why did I do that? 5 and 2 is the answer that you're going to want. All right, let's continue on. Let's look at example number 4. And same kind of idea. We've got a problem that you could use elimination with, but they said use substitution. So we will do that. Okay. So which one do we solve for? Which one do we say x equals such and such or y equals such and such? Well, as you get used to this, you'll start looking and saying, well, I don't have anything in front of this y, so let's make this equal to y because that's the simplest one. This one, if you try to set it equal to y, eventually you're going to have to get rid of this 4. And it's just easier if you don't have it to mess with. So let's take the second one here, add 3x to both sides. And then that gives us y equals 3x plus 6. And I have no idea why that little curly Q is on there. It just kind of got on there. All right. Now whenever we see a y in the first equation, we're going to put 3x plus 6 in its place. Okay, so let's distribute. And combine those like terms. Subtract 24 from both sides. So divide by 10, divide by 10, x equals -1. Okay, so now let's take it and plug it back into one of the white equations up there. So let's take the first one. So that gives me a 3. And subtract 3, and we get y equals 3. So my answer then is -1, 3, for example 4. Okay, so you'll notice as you're going, things get a little bit more complicated. All right, so I'm going to stop right here and start with 4.3, B as in boy, and then included with that B, we'll do some problems from the problem set.